Hello everyone, in this video let us solve this question together. So we have t raised to power t is equal to 49, and here we to solve for the value of t. So t is the unknown we have to solve for. To do this, solution. So we have t raised to power t is equal to 49. Now this question is that you will pick a particular number, and that number, once you raise it to that same number, you must get 49. Now let's say we try to test it out. We try 1 raised to power 1 is equal to 1, and this is not equal to 49. If you try 2 raised to power 2, this will give you 4, and this is not equal to 49. If you keep on testing it, you try out 3 raised to power 3 is equal to 27, and this is also not equal to 49. If you try 4 raised to power 4 is equal to 256, and this is not equal to 49. But right here, if you look closely, 3, which gave us 27, and 4, which gave us 256, the number 49 we're looking for is in between 27 and 256. So that means that in between 3 and 4, the number 49 right here is in between the values of 3 and 4. But then it cannot be a whole number. It will be a decimal number, something like 3.1, 3.2, and thereabouts. But it will take time if we keep on testing it, but we can get the actual value that will give us 49. Now, to do so without any stress, we can simply solve it this way. So to solve this, we are going to introduce natural logarithm to this equation. So this becomes ln t raised to power t is equal to ln 49. Now from here, we are going to apply one of the rules of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this rule right here, what we then have is this, that power t becomes t times ln t is equal to ln 49. Now at this junction, first to solve for the value of t, the next thing we're going to do is to introduce what is called the Lambert W function. So we call it the Lambert W function. Now, what exactly is this function? Now, suppose you have an expression of this form. Let's say you have 3 times e raised to power 3. If you have an expression like this, if you apply the Lambert W function to this, what you will get is 3. Now, let's say you also have y times e raised to power y. If you apply the Lambert W function to this right here, what you will get is y. So, but for us to apply this Lambert W function to this equation, we must first have to manipulate this to resemble something of this form. Now, to do so, we are going to introduce a special function which is called e raised to power ln x. You see, if you have e raised to power ln x, this will give you x. Why? Because e will cancel ln, x will stand alone. Same thing right here. We can say if you have e raised to power ln t, this will equal t, because if we cancel ln, t will stand alone. So therefore, in place of t right here, we can bring in e raised to power ln t. So this becomes e raised to power ln t, then we have times ln t is all equal to ln 49. So from here, if you look at this expression right here compared to this form, you'll notice that e is in the second place, but right here e is in the first place. So we are going to move e to the second place. This then becomes ln t, then times e raised to power ln t is equal to ln 49. So looking at this right here, this is in this form. We can then apply the Lambert W function. So W into brackets ln t times e raised to power ln t is equal to, also apply it right here, W times ln 49. Now, if you do so right here, if you apply this function right here, what you are going to have is ln t, which equals W times ln 49. Now at this junction, the next thing we're going to do is to remove this link from here to solve for t. And to remove this link from here, we're going to introduce e. Now you see e raised to power ln t is equal to e raised to power w times ln 49. From here, if we cancel ln, what do you have? We have t is equal to e raised to power w times ln 49. Now, with this, we have gotten the value of t. But then if you are wondering, okay, why is the value of t not in numerical form? Now, to actually get the numerical form for t, simply in your calculator, press e raised to power. Now, in some calculators, you will not see w, but instead, you will press product log to replace w. So type in product log. So e raised to power product log, multiply it by ln 49. If you do so, what you will see in your calculator, the value of t will be equal to 3.27804. This is in 5 decimal places. So we can approximate it to 4 decimal place, so that the value of t is approximately 3.2780. So this is the value of t right here. Now back to the question. If you raise t raised to power t, which will give us 49, the value of t is this. So therefore, if you raise 3.2780 to 3.278080, you will get the value to be approximately 49. Okay, so with this, we have gotten the value of t that satisfy the given equation. So I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Please do it to please subscribe. Thank you very much. See you in the next video. Bye.